Students, good afternoon. So today we are going to discuss about operational amplifier basics. So based on design thinking. So we all know that what is design thinking. Can anybody say what is design thinking? Yes.
It's a human-centric approach to develop a product.
Yes, it is correct. It is a human-centric approach that is mainly understanding the human, that is customer requirements by collecting feedbacks through interviews, through observing user needs, and through surveys. We can collect the information about their requirement and feedback and develop innovative solutions to develop a product. So mainly it is used for engineering, software development and product design. So also we are familiar with the different stages of design thinking. What are the different stages of design thinking?
5 stages of design thinking. Stage 1 is empathy, stage 2 is define, stage 3 is ideate, stage 4 is prototype, stage 5 is testing.
Oh, so there are 5 types. So the first one is empathy. Empathy means to collecting user feedback. As I already said, the user feedback can be collected through interviews, surveys, by observing the users. So through this we can collect different types of feedbacks, and based on this we can develop a product. And the next stage is define. So collecting all the points, that is observing all the points from the empathy, and we can give a correct problem statement. This is a definition. That is the second stage, define. And third stage is ideate. Can anybody answer what is ideate?
Ideate is the process of generating the different types of ideas and solutions to the problem.
Okay, so after defining the problem statement, we can generate different innovative ideas by brainstorming and mind mapping. Using this technology, we can ideate many innovative solutions. And other two stages are that is a prototype, and all this 3 stages we can design a product, and the testing is the last stage of design thinking. So based on design thinking, we are going to discuss about operational amplifier. So before that, we should know what is amplifier. What is amplifier?
Amplifier is an electronic device that is used to strengthen the signal.
Strengthen the input signal. So amplifier. So in earlier days, the amplifier is mainly used for strengthen the input signal. We can see in functions and in temple functions, we can see the speaker. That is the volume. The volume is increased. That is the sound signal is strengthened. Okay. So in modern days, it is found that the amplifier can be used for performing mathematical functions. That is addition, subtraction, multiplication, division, integration, and differentiation. So that is why it is called operational amplifier. That is, for performing mathematical operation, it is called operational amplifier. So how the amplifier can be used for doing mathematical amplifier means, so there are, that is feedback, using feedback. So what is meant by feedback?
Feedback is some of the part of the signal is fed back as input.
Okay, so the output, the pattern of output is fed back to the input. It is called feedback. That is, output is fed back to the input signal. That is called feedback. So there are 2 types of feedback signal. That is positive feedback and negative feedback. So in positive feedback, the output signal, that is the feedback signal, is added with the input signal. So in positive, that is plus. So the feedback signal and the input signal is added. Okay. So mainly it is used in oscillators. Okay. So it improves the gain, but it produces instability. Okay. So the next one is negative feedback. So the negative feedback is mainly used in operational amplifier. So amplifier plus negative feedback is called operational amplifier. So it increases the stability, it increases the gain, also it increases the bandwidth. Okay, but so some of the gain is reduced. This is the main problem, but it increases the stability. Okay, so in negative feedback, the feedback signal is subtracted from the input signal. So this is about the feedback signal. Okay. Okay, so this is the symbol of operational amplifier. So this is a 8-pin IC. It is a 8-pin IC. The first pin is offset null. The 1 and 5 are offset null. Second pin is inverting terminal. Third pin is, that is plus symbol, is non-inverting terminal, and fourth pin is minus VCC, and sixth pin is output, seventh pin is plus VCC, and eighth pin is not used. And this is the symbol of operational amplifier. So the IC number is 741. So this is your inverting terminal minus, this is non-inverting terminal plus, and here we are taking our output, and here we are giving the supplies. Okay, we have seen the pin details and the symbol, and there are some ideal characteristics for the operational amplifier. So the ideal characteristics are infinite input impedance. So that is Rn is infinite. So resistance, opposition is very high. So it ensures that no current flows in the output amplifier in an ideal stage. Okay, and zero output impedance and zero offset voltage. Here I want to explain offset voltage. So generally operational amplifiers amplifies the difference between the input signal applied at inverting and non-inverting terminal. So suppose if we apply two input signals are same, the output should be 0. But in practical there are some voltage available in the output. It is called offset voltage. And infinite bandwidth, infinite CMRR. So that is CMRR means common mode rejection ratio. Common mode means if the two input signals are called, it is called common mode, but it should be 0. The output should be 0. So there is a small voltage at the output in practical applications. So it should be rejected. That is called common mode rejection ratio, and infinite slew rate. So these are the ideal characteristics of operational amplifier. Thank you students. Hope this session will help you to understand what is feedback, what is operational amplifier, why it is called operational amplifier, and the pin details, and what are the ideal characteristics of operational amplifier. Thank you.
Thank you.